These are some of the problems on page 254 on tonight's homework. And so there's three parts to this lesson, so this is part one. So let's take a look at the first problem here. They ask us a bouquet of, give us some information. A bouquet has 6 red, 8 pink, 12 yellow, 2 white flowers, each ready ratio in all three forms. Well, for number 2, they say red flowers to total flowers. Well, we need to figure out how many red flowers there are, and it says up on the top here there are 6 red flowers. So we're going to write 6 red flowers. Now, notice it's red to total. So red has to go on top. So we're doing the 6 red flowers on top, and we're going to end up writing the total flowers on the bottom of the fraction. Now, we're going to write each ratio in all three forms. We're going to do it in this 3 different ways. So red is first. So 6 over the total. We've got to add up all these numbers. So we got 6 plus 8, so that makes 14, plus, and then we have 12, so we've got a plus 2. So I'll add up the 12 and the 2. That makes another 14. 14 and 14, well, that gives us 28. 28 total, so 6 over 28. Now, they might want us to reduce that fraction, so let's go ahead and do that. If they didn't, then we'd use 6/28. But I'm going to go ahead. I like to reduce fractions. So let's go ahead and take out a common factor between these numbers. And I see that 2 goes into each of those. And so I can go ahead and do that division. And when I do that, I'm left with a 3 over, and this gives me 14. So that's the one way to write that. Now the other ways to write that would be just as they have here, using the word 2 in between. So red flowers would be 3 to 14. Or we could also do the method using the colon. So 3 to 14. So those are the different methods to use there. Number 3, at concession stand sold 14 strawberry, 18 banana, 8 grape, 6 orange fruit drinks. During a game, tell whether the ratio of strawberry to orange or ratio of banana to grape is greater. So let's do the strawberry to orange first. So strawberry, go over here to strawberry. There's 14. So 14, I like to use the fraction form here. You'll see why in just a moment. Now, 14 is strawberry. Orange. Orange is 6. Okay, so we got that one. Now, I can reduce this. Let's go ahead and do that. This would be the same thing as if I divided by 2, it would be 7 over 2. So this is the one that is strawberry to orange, S to O. Okay, now let's do banana to grape. So banana is 18. So we got 18 on top. And we have grape. Grape is 8. So 8 on the bottom. Do the same thing. Let's take out that common factor of 2. And that just makes the fraction smaller, 9 to 4. And so this was banana to grape. All right, so we know which one's which. Now we want to figure out which is the greater. Well, what we can do is you can either divide. You can divide the number 2 into 7, 4 into 9, or you could use cross products. And so we'll go ahead and set it up this way. We'll do 7 over 2. And see if it is, we'll do 9 over 4. I want to go ahead and come up with that common denominator, see which one is greater. So I'm going to multiply this one by 4. And see, cross products would be 4 times 7. Multiply this one by 2, and then we'll have the same denominator, so we can compare them. And so you can't compare fractions unless they have the same denominator. So it's not, people might think, oh, 9/4 is bigger because it has a bigger number, 9 over 7. But we'll find out at the end. So 4 times 7 makes 28 over 8. And then over here we have 18 over 8. So this is the bigger number, 28/8. So that's the one that's strawberry to orange. So the one that is greater, well, that would be strawberry to orange. All right, so let's move on to another one. A 5-gallon jug is 41.5 pounds heavier when it is full of water than when it is empty. Okay, so this is how much heavier it is. So 5-gallon bucket is this much heavier Okay, so how much does the water weigh per gallon? Well, that's how much it weighs right there, because it's that amount heavier. And so we want to find out how much does water weigh for 1 gallon. Per gallon means just 1 gallon. Well, what we want to do then is we want to set up a ratio, and the ratio is going to be this. This tells us what that ratio should be. The per is the fraction bar. So what we're going to do is we're going to do weight per gallon. So the fraction bar represents the word per. So weight, okay, weight's got to go on top. That's the 41.5 pounds. The gallons has to go on the bottom. Well, that's 5. All you have to do now is just reduce the fraction. They want to know per gallon. So they want to know, well, how much is it when the gallons is just 1? And that's what we did here. We divided by 5. So off to the side here, I'm going to do 5 into 41.5. So 5 goes into 41 8 times. That makes 40. Do some subtraction and add that decimal point. And it goes into 15 3 times, and that would be evenly. So there it is. It is 8.3, and then this weight was in pounds. So it's pounds, LB stands for pounds, per gallon, per 1 gallon, and there would be our answer. Well, number 6, grocery store sells 7-ounce bag of raisins for $1.10. A 9-ounce bag of raisins for $1.46. And which bag has the lowest price per ounce? There it is again, price per ounce. That tells us right away, this is what I look for. That tells me how to set up the ratio. We want to know the lowest price per ounce. So, unlike this one here, we want to know which one's greater. Here we want to know the less. So price per ounce, dollars per ounce. So that's how we're going to set up our ratios. So it's kind of similar to this number 3 problem. So let's set it up. A grocery store sells 7-ounce bag of raisins for $1.10. So $1.10 has to go on top because it's the dollars. So $1.10 over 7 ounces. So we want to see, is this one bigger or is it this other one, which is a 9-ounce bag for $1.46. So $1.46 for a 9-ounce bag. Well, let's do this. Let's go ahead and find the unit rate, the price per ounce, kind of like what we did on this problem up here. Let's do it for this one here. Let's divide this by 7. See how many times it goes in there. So let's, off to the side, we got 1.1. We're dividing by 7. So 7 doesn't go into 1, but it does go into 11. It goes in there. We have 1 time, which makes 7. We do the subtraction. We're left with 4. So we have to add a 0. So it goes into 40. We got 5 times and makes 35. 5 left over. Add another 0. It goes into 50. We have 7 times. And that's as far as I'm going to go because we're going to just do dollars and cents. Cents ends after the second value. So this tells us right away this is going to round up. But let's just leave it like that for now. Let's leave it as this one here was $0.157 per ounce because maybe the other one is going to be like 0.153. So let's leave the 7 there for now. And or it could be 0.156. So I don't want to round quite yet. So let's do the next one. We're going to divide this one by 9 over 9. And so we set up the problem 9 into $1.46. So we go ahead and do the division. And I've got 9 goes into 14 1 time. Do the subtraction. That leaves me with a 56. Goes into 56 6 times. Oh, I figured it out right there. 54. So I don't have to go any further than this. See, if I did this, I would have to subtract. I get a 20, and if I did add in one extra number, it would only go in 2 times. So there it is. The other one's going to be $0.162. So it's probably good that I didn't round it, because if I rounded it, I would have rounded it to 16 cents per ounce. This one was 16.2 cents per ounce, or $0.162 per ounce. So which is the cheaper one? Which is the lowest price per ounce? It's this one right here. It's the first one. It's the one that was $1.10 for 7 ounces, was a little bit less. Well, part 2, we'll go over the next 2 sections.